first, we have rational expression. What is rational expression? It is an expression that can be written as a ratio of two polynomials, as what you have seen in the previous example. So here, our example of rational expression. So first, we have 2 over x, that is a rational expression. Second, in the middle, x squared plus 2x plus 3 all over x plus 1. The one given in the example. And then, here we have 5 over x minus 3. Now, let's move on to another term. The next term is rational inequality. So, what do you mean by this? Rational inequality is an inequality involving still rational expression. So, that means there is a ratio of two algebraic expressions. So, here we have 5 all over x minus 3 lesser than or equal to 2 over x. So, what makes it inequality is because of the symbol in between. That is not equal. It's lesser than or greater than or equal to. So, those symbol determines inequality. Okay, so you can say that that expression is rational inequality because of those symbol. So, how to solve rational inequalities? So, first, you have to rewrite the inequality. Make sure that the inequality is in standard form. It's like a quadratic equation that you have to is make it standard form. It's like the other side is 0 and the other side is the expression. Okay, the rational expression. Next is determined over what intervals the rational expression takes on a positive and negative value. So, you need to do that because that will guide you in the answer later on. Next is locate the x values for which the rational expression is 0 or undefined, because those values you need to avoid since it's undefined. So that means your rational inequality will not be satisfied. So we need to locate these values. The number 4, mark the numbers found in a number line. And then for the numbers that is included in the solution set, you need to use a shaded circle. Shaded circle to indicate that that number is included in the solution. And for not included, that number that is not included, you need to put a circle, a hollow circle. Okay, for the values that is not included in the solution set. So again, you know what is a number line and you know what is a shaded circle and a hollow circle. Use shaded circle for included solution set. Use a hollow circle to indicate that the value is not included in the solution set. Next, number 5, select a test point within the interior of each interval and summarize the intervals containing the solutions. So, let's go on to the real example. But before we move on, we need to take heed of the warning. What is the warning that we need to take note? Make sure that multiplying both sides of an equality by a number requires the sign, positive or negative, of a number is known. So, now, in inequality, since the sign of a variable is unknown, it is not valid to multiply both sides of inequality by a variable. So, we will not multiply it, the variable, because the variable has no sign, positive, negative, it's just a variable. So, that's a warning. We need to make sure that we will not apply this thing because for sure our answer will be wrong. We need to take heed of the warning. Now, we have example number 1. And example number 1 is solve the inequality 2x over x plus 1 greater than or equal to 1. Okay, so here, the first step is we need to rewrite it into standard. One side will be 0 and the other side is the rational expression. So this is what will happen. Okay, there. This is the answer. We transfer 1 to your left side and then we replace the original position with 0. So here comes now, the other side is rational expression, the other side is 0. So after that one, what do we need to do? Find the LCD. So what will be the LCD? The LCD is the denominator. Since we are having this one fraction and then a whole number, automatic the LCD will be the denominator. So the denominator will be the LCD, and just simply copy the numerator, then minus what will be the expression for the second term. Well, just simply cross multiply the denominator x plus 1 to the whole number 1. Multiply them. X plus 1 times 1. The answer is still x plus 1. So that's why there we write 2x minus the quantity of x plus 1 all over x plus 1 greater than or equal to 0. Why there is a parenthesis? There is a parenthesis because the operation before is minus. That means the sign will change later when we simplify. So after this, we need to simplify. So the answer will be x minus 1, x plus 1. Okay, very good. So as we distributed, so that will, the x will become negative, so that will be 2x minus x, and then the 1 plus 1 there will also be minus 1. And then simplify 2x minus x is x, so that will be x minus 1 in the numerator. Then denominator will remain the same, x plus 1. So this is now our inequality, the simplified inequality. X minus 1 all over x plus 1 greater than or equal to 0. So now we can proceed to the next step. What's the next step? So the continuation, as you can see, we need to remember that the rational expression must not be undefined. So what will be the value of your denominator where the expression will be undefined? So in here, in our next step, that is we need to identify the rational expression will be 0 at x is equal to 1. Okay. Now, 0. Because if you will substitute 1, 1 minus 1 is 0, and then 1 plus 1 is 2. 0 divided by 2 is 0. And undefined for x is equal to negative 1, because negative 1 minus 1 is negative 2, and then negative 1 plus 1 is 0. Negative 2 divided by 0 is undefined. It's a no-no. So the value of x is equal to 1 is included because it's okay, it's not undefined, while x is equal to negative 1 is not included in a number line. Okay, so we can mark this in the number line. And again, for 1, positive 1, it's included, shaded circle. But for negative 1, it's not included, so that is a hollow circle, as you can see in the picture. So you have there, for positive 1, it's shaded, and for negative 1, it's a hollow circle. And then, let's continue. So now, we need to be specific as to what are the values of x that will satisfy the given inequality. We only determined negative 1 as not part of the solution, and we also determined that positive 1 is part of the solution. But what are those numbers starting from positive 1 and also from negative 1? Is 0 included? In between positive and negative 1, is 0 included? So that's what we need to test. So in here, we need to test the points in the intervals determined by negative 1 and positive 1, so that we can be specific as to what are the values of x that will satisfy the given inequality. So we have here the interval and the test point, and then you have also the numerator x minus 1, you have the denominator x plus 1, and then you have the rational expression x minus 1 all over x plus 1. So we need to test them first. What if, let's say, the value of x is lesser than negative 1? When we say lesser, so what are those numbers lesser than negative 1? So perhaps we have, let's say, negative 2. So substitute negative 2 to the test equation here. So you have x minus 1. So that means negative 2 minus 1, the answer is still negative. And then here, x plus 1, substitute negative 2, Negative 2 plus 1, the answer is still negative. And then when you substitute negative 2 to the rational expression, x minus 1 all over x plus 1, so that will be negative 2 minus 1 is negative 3. And then negative 2 plus 1 is negative 1. So negative 3 divided by negative 1 is positive. So the answer here is positive. Now let's move on. That's lesser than negative 1. Okay, so next, what if in between? In between positive 1 and in between negative 1. Okay, so you have what if, let's have 0. That's in between. So when you substitute, the answer is negative. When you substitute to the second, the answer is positive. And to the rational expression, the answer is negative. So now, let's continue. The last one is greater than positive 1. So that means 2 onwards. 2, 3, 4, 5, blah, blah, blah. So let's start. We'll use only the smaller number, which is 2. So substitute it. The answer is positive. All positive. So that's the answer when we test the points. So now it's time for conclusion. Among these given test points interval, which one will make our inequality true? Remember, our inequality is x minus 1 all over x plus 1 greater than or equal to 0. So when we say greater than or equal to 0, that means it will be positive. Our answer will be positive numbers. So as you can see on the table, in the rational expression that we have, x minus 1 all over x plus 1, among the three intervals that we have, which one give us a positive answer? We have x lesser than negative 1, and we have also x greater than positive 1. So that means those are the solutions. So here are our conclusion. So here we have to conclude. Again, we are looking for the intervals that will make our inequality true, or our inequality will be satisfied. So the value of x is that lesser than negative 1 and from 1 to above. Okay, so that's why in here in the set, the values of x is the set of all real numbers such that your x is lesser than negative 1, or your x will be greater than or equal to positive 1. And that is what you can see in the number line. So for negative 1 onwards, negative 1 is hollow circle. That means it's not included. And then for positive 1, it's shaded circle because that means positive 1 is included in the solution set. We have now example number 2. Example number 2 is solve the inequality 3 over x minus 2 lesser than x lesser than 1 over x. So we have the solution. What will you do is to transpose 1 over x to your left side. Again, equate it. One expression must be 0. One side of the expression must be 0. And then the left side will be the rational expression. So as you can see in here, we already did that. Then find the LCD. What will be the LCD? The LCD is x minus 2 times x. So there you have the denominator. The LCD is x times x minus 2. And then for the numerator, so just cross multiply. 3 times x. So you have there 3x minus. Then x minus 2 times 1 is quantity x minus 2. Same. So again, there is a parenthesis because the sign will change later. So we need to simplify that one. So the final answer will be 2x plus 2 all over x times x minus 2. So we have the answer. We need to factor out 2 times x plus 1 all over x times x minus 2 lesser than 0. So from this expression itself, this means that we are looking for the values of x that will be lesser than 0. What are those numbers lesser than 0? That means negative number. So our answer must be negative. We are looking for negative. So in here, we will get the points or the values where our x will be 0 and our rational expression will be undefined. So what are those values? So first, since we have already simplified the inequality, so our inequality now is 2 times the quantity of x plus 1 all over x times the quantity of x minus 2 lesser than 0. Again, lesser than 0. So here we have the rational expression will be 0 at x is equal to negative 1. And then undefined if it is 0 and 2. So we need to plot it on the number line. So hollow for the circles are not part of the solution. So you have negative 1 hollow because the inequality is lesser than 0. So if you have 0, that means it's equal 0. So it should not be part because it's lesser than 0. So negative 1 is hollow also. 0 is hollow and 2 is hollow. So next, test the interval. So we have here, construct a table by determining the interval that we had on the number line. So we have the interval test point, the numerator, the x, the denominator, and the rational expression. So we have here, what if we have lesser than negative 1, negative 2? So it's all negative. What if we have in between negative 1 and 0, let's say negative 1 half, we have positive. And then for in between 0 and 2, we have negative. And then for greater than 2, we have positive. So now, among the given interval, which one give us or satisfy the given inequality? Okay, we have 2, negative. Because we're looking for negative to satisfy the inequality. So that will be the interval of x lesser than negative 1 and x is greater than 0 but lesser than 2. So we have here the conclusion. So the interval, the values of x in the inequality, the solution set of the inequality is the set of real numbers such that x will be lesser than negative 1 or x will be greater than 0 but lesser than 2. So you have here the illustration. So starting from negative 1, that's a hollow circle, and then you have the arrow there, and then in between 0 and 2. So the line there, it's bold line, so that means that's the solution.